Hello lovely people, did you know that ATOTO makes not only head units, but amplifiers, speakers, and subwoofers as well? I didn't know that. So in this video, we'll be checking out this, the underseat subwoofer CS-101SW. Before we start, as always, I would like to thank ATOTO for sending me all of this. Apparently, they kind of like what I'm doing with all the objective measurements and data. So today we'll be looking at this 10-inch active underseat subwoofer. You've seen many of these online. They go under very different brands. They are slightly different from each other, but at the same time, they're very similar in design and use case scenario. So first, I want to touch on this word subwoofer. Technically, anything that is playing below 100 hertz is classified as a subwoofer. However, people online always expect that anything that has a subwoofer name in it will play 20 hertz at like 140 dB SPL or something stupid like that. This is not the case. This is called a subwoofer, but it's more like a mid-woofer, mid-bass driver, and this is exactly the use case scenario for it. You wouldn't want to use it as your main dedicated subwoofer in the very back and let's say let it play all the way down to 30 hertz. This is unreasonable and, to be honest, very optimistic. So let's unpack it. Let's see what's inside. And in this video, what we're going to do, we're going to take some objective data. So we're going to have a look at how the driver performs itself. We're going to have a look at impedance graph, near field response, far field response in the car in different locations. And we will test the built-in amplifier, how it performs, how clean it is, and how much power it can put out. Now, this subwoofer in the UK, it is bloody heavy. It costs about close to £200, I believe, on Amazon. So it is on the expensive side compared to all the others, because you can find them cheaper for, I don't know, 120, 150. But I guess in this case, you're paying for the quality of the brand and probably the customer service as well, because most of them will be like white label brand or no brand at all, and you're gonna have no customer service. With this, you're getting that. So when you're paying a little bit extra, you know that you're getting basically after sales support. So in the box, we do have a remote bass knob. So we have your typical telephone cable. This bass knob is plastic, it's very light. It does feel cheap, but again, this is a budget product as well. In the other bag, we have a manual. We do have some mounting hardware with these little tabs. And we have, are these sticky pads or Velcro? Velcro pads, yes, Velcro, because this subwoofer needs to be fixed to the car somehow, so it's good that everything is included. Now, since this is an active subwoofer, active means that it has a built-in amplifier inside. It comes with some wiring as well. If you would have a passive one, you would have literally nothing. But an active one comes with all the wires that you need. So we have our positive lead, the black one is ground, and the blue one is your remote wire. Now let's take it out and let me show you. There we go. Let's have a better look. So this is how it looks like. You've seen these. A lot of people did reviews on them, and this is what I don't like about those reviews, because what they do is they put it in the car, they crank the volume up, and they complain that it doesn't play bass or is distorting or something. What you have to do with any kind of product that you're using, you have to have realistic expectations, and you need to know what the product is designed for. So obviously, being so slim like that, it is not designed to replace a full-size subwoofer. A normal like 10-inch subwoofer would weigh as much as the whole thing, would cost probably as much or more as the whole thing, but would be like 3 times as tall and as big. And you would need an enclosure that's like, I don't know how many times bigger. This enclosure, I want to say it's like probably 0.2 cubic foot, extremely small, extremely shallow, and this is designed to be used in very, very tight spaces. Mainly is going to be under the seat. However, in my video, we will be testing this as a front subwoofer application as well, because this should fit in a footwell very, very nicely. And if you can use something like this for 200 quid or maybe less as a front subwoofer, you don't need to fabricate anything. You just literally pop it in, make a beauty panel on top, connect all the wires, and you have a fully functioning front subwoofer, which is amazing. So let's have a closer look at this thing. The whole enclosure itself is made out of metal. Now, first you would think, why not plastic? Obviously, plastic would be cheaper, it would be lighter, it might have the same strength because plastic can be strong as well. However, you need to remember that this has a built-in amplifier that needs cooling. So all the metal that the subwoofer is made of is mainly to do with the cooling, because again, you're going to put it somewhere under the seat where there's absolutely no airflow, no nothing, and it has to cool passively. There's no active fans or anything, so it has to have a huge thermal mass, and this is why it's made out of metal. These tabs, as I mentioned before, the hardware for mounting, like these, they go in here like that. You screw them in with 2 little bolts, and then you screw the whole thing to wherever you're mounting, because these things need to be mounted solidly for them to perform their best. If you're gonna just plop it in and leave it there, everything is gonna vibrate and you're not gonna get the most output of it. When you tighten it to the floor, it's exactly the same principle with any other subwoofer. When you bolt the thing to the car itself, all the acoustical energy that's coming out of the speaker will be converted into sound instead of the actual box or like subwoofer vibrating and losing that acoustical energy. So remember, bolt it. So, cables and connections. If you have a look from the front like that, we have a few adjustments. As always, we have our gain knob, bass boost, crossover. Crossover goes from 50 to 150. Input on RCAs and on high levels as well. So, for example, using this plug, which is a typical Molex plug, these 2 wires for the ground, these 2 wires for the power, this one for the remote, and then you have your high level connections that should come from stock radio if you're using. So you just hijack the speaker level outputs and you plug it in into here with, again, typical Molex connector. Probably they sell this as well. Now the power wire and the remote, it extends with these bullet connectors. So for a remote wire, I think it's kind of fine, but for a positive, I would want to see a better connection than a bullet, but I guess it's gonna work because it's not a huge current draw anyway. One thing that I want to note is that the gauge of the wire is very different from power to ground. So power is quite thicker wire and ground is 2 of these smaller ones. Now granted, the ground wire is shorter than the power because this is kind of designed to be run through a firewall. That's why it's so long, so you could run in directly into the battery. It does have an inline fuse. Actually, let's check because I don't remember what was the value of the fuse. 10 amps. That's, I don't know, you probably won't be able to see. This is a 10 amp fuse. So for a wire size such as this I think is going to be, I want to say 12 or 10 gauge. Does it say on the wire itself? Yeah, 2.5 mil. So 2.5 mil converts into gauge. I don't remember. I think it's 12 gauge. And ground, again, is a little bit, it's a bit weird. They could do exactly the same with a ground wire. Just have a bullet and extend it into a much thicker. Ideally, you would want your power and ground to be the same gauge. However, again, it depends on the length. If you have a shorter cable, in theory, based on Ohm's law, you could have a thinner ground, which is not a problem. Okay, let's come back to this. So your inputs, ground, power. This fuse is 20 amps. So I have 10 amps on the power wire and 20 amps here. And you might say that it doesn't make sense. However, this 20 amps is for the built-in amplifier that would deal with like massive current spikes when you have a bass hit. So it's fine. Then we have our remote, power protection phase, and this EBC and remote. I do believe this is how this thing is turned on. Let's check the manual. Okay, here it says number 1, use the switch to power up or turn off the subwoofer. So it's either power switch or high level and remote wire. And from other sides, you have nothing. Everything is very, very plain. Here we have a ATOTO 10-inch. It's rated 150 watts RMS, 400 watts peak, made in China, designed by ATOTO. Now, one thing that you notice probably is this. What the hell is this? This is not a port. This is a passive radiator. I was looking at other these undersea subwoofers. I've never seen this. All the other ones just have a sealed enclosure. However, this one has a passive radiator. So when we're going to do the impedance sweep, we will see if this actually acts as a passive radiator, because we're going to see two peaks and a dip between them, or it just does nothing and we're going to have just a single peak. So now what I want to do is I want to take it apart and I want to show you what's inside. While I'm taking it apart, I want to show you that there's another screw here in the middle under the sticker, because it is screwed down to the actual speaker. So if we unveil what's inside, we have a little bit of like padding or filler, if you want to say. This is the 10-inch driver, and here on this side, this is the amplifier. So we have our power supply with FETs here and here, I imagine, primary capacitors, secondary capacitors, and this is the output with two FETs. So this is a class AB amplifier, so it's not efficient. That's why it needs such a massive heatsink, and all of this, as I mentioned, acts as a heatsink, because you can see they're screwed down with thermal paste and they are cooling through this thing. Speaker outputs, it goes into there. Now I did measure this driver is a 3 ohm driver. Actually, we can have a look at it a little bit better if I'm gonna take it out. There we go. So, flat cone, totally flat. It is very stiff. Like the suspension of it, yeah, it is stiff. The actual cone seems to be metal, probably aluminium, because I think is the only way how you can keep it flat. And again, when you have a subwoofer like this, a shallow mount, which is like literally nothing, you cannot expect it to have high excursion and a high output. That's why do not expect these subwoofers to play, I don't know, below 40 hertz. They're not designed for that. Power handling of 150 watts seems reasonable for this size of motor structure and this kind of magnet. I cannot see the coil, I cannot see the spider, because everything is so shallow. Everything is hidden, so it's impossible to see anything. Now we do have this foam on the top of the speaker, because when the enclosure goes together, the magnet sits here and this bolt goes through here and everything is kind of squashed, so you know there's not going to be any rattle or anything. And this thing here is our passive radiator, so it is very stiff. Everything, to be honest, is stiff, so my guess, this subwoofer could take much more power than this amplifier can supply. We're gonna see how much it does, but yeah, this is basically how it looks like. So while I had it apart, I took the impedance sweep, I did the amplifier measurements. Now with the impedance sweep, with everything put together, I tried to put a gasket all around and just squash it and take the impedance graph. So I think we're gonna see a little bit of a dip in there, but it's not gonna be that accurate. So now I'm gonna connect it just for you to have a listen how it bumps. One thing that I want to show you before the actual demo is this gain knob, and this is for ATOTO. ATOTO, you naughty guys. Look, this usually, when you have a gain knob, on the left side you have the maximum voltage with the gain all the way down, which should be 4 volts. And on the other side, when you crank the gain up, you will have the smaller voltage, but this is the other way around. And first I saw this and I thought, okay, maybe is the pot. So I turned the gain all the way to that side and it was so loud I almost blew it. So this is wrong. This is the other way around, because if I'm gonna turn the gain up, look what happens. See, it goes louder, and down it goes lower. So this should be 4 volts, this should be 0.1 volts. Now, how does it sound? If I'm gonna put it here, all of it, see? This rattles. So yeah, it does have quite a lot of output, especially in the car. We're gonna see how it does, but no weird sounds. I think the cone may be at higher bass frequencies. Let's have a listen. I don't know, maybe it's the sound because it's just YouTube royalty free stuff. We're gonna have a look at the distortion and everything. So, I don't know. It does sound solid. It does a little bit vibrate. It's not rattling, it's not flexing, it's just the whole thing vibrates because it has so much output. You know? Okay, that's enough for this nonsense. What I want to show you now is how it heats up through a thermal camera. So I will be playing just a sine tone, and I want to thank Sinewave02. You can find it on TikTok, YouTube, Instagram, probably everywhere. He let me borrow one of the Thermal Master thermal cameras. So a huge shout out to him, and look what's happening with this subwoofer. So you can see at the moment I am playing, you won't be able to see, I wanted to show you 60 Hertz sine tone at a reasonable level. Now outside temperature you can see we have 13 degrees, 15, outside is sunny. Now the subwoofer itself, you can see the chassis is about 25 degrees something, and here you see it heats up. So this is where the output FETs are. We have power supply on this side, so the power supply doesn't heat up as much, but the output FETs are heating up. So now it's like 37, it's hovering something about 37 degrees C. Now I stopped it, it's raising about 40, so I did this test for about 5 to 10 minutes. It's hovering about 40 degrees. It doesn't get any hotter, and now it kind of cools down. So basically this part that is getting hot, and then it kind of distributes the heat through the whole heatsink, and this is why it's made out of metal. Something is a bit rattly here. Yeah, it's playing nice. Let's measure. Okay, we're gonna start with the impedance, which is the most simplest one. So we do have, as I mentioned, this driver is 3 ohms DC, 3 point something, so it is close to 4 ohms. I wanna say it's a 4 ohm driver. The FS is about 42 hertz, which is quite high, but for a stiff suspension, 10-inch, it's kind of okay, I want to say. And we do have this bump at the impedance graph at about 350 hertz. We will come back to this where we're going to have a look at the frequency response. So bear in mind that there is a bump here, and the inductance is quite big, to be honest, quite huge, because it's a very, very sharp rise to the top. If we correlate inductance with distortion, we can expect that this driver is going to have a little bit more distortion. So this is in free air when the driver is taken out of everything. This is when I screwed the driver back onto the front baffle, but the box is open. So we do have a bump in the impedance graph here. I am not sure why. And the last one is I try to close it to measure with a passive radiator, and I have this, which is, it doesn't really help. So like if we're gonna go down, we kind of see one peak here and one peak, but this is just because it's so leaky that it doesn't register as normal impedance. But if we have a peak here and peak here, we can say that the tuning of the passive radiator is about 45 hertz, like in between these two. So roughly we can say that this enclosure is tuned between 40 and 50, which would make sense. Now we're gonna have a look at the amplifier first, and then we're gonna have a look at the RTA, because this will explain quite a lot. This is a power versus THD on this amplifier. In my book, as I mentioned, everything between 0.01 and 0.1 in this area is kind of okay. Everything above 0.1 is kind of bad. Considering that this is a budget monoblock and it is designed to be used on a subwoofer, this result 0.1 is kind of respectable, I want to say. I don't see anything wrong with it. Now, the clean power we have up to 65 watts. This was measured at 13.2 volts, as always. And 1% THD here, we have about 75 watts. It is advertised as 150 watts RMS. My guess that 150 watts is more for the subwoofer driver thermal handling, not the built-in amplifier. Because as I mentioned, the magnet, the motor structure and everything, it looks like it could handle 150 watts. An amplifier is half of that. And this is what's happening most of the time with these active subwoofers in general, that if you push them too much, the amplifier is gonna blow first, way before the actual driver. I don't know if you've seen, like on Facebook Marketplace, where they sell any kind of active subwoofer. A lot of times amplifier is blown and they have wires sticking out of the box and run them on the external amplifier. Because it is a weak amplifier, you would want much more power on it, but it cannot deliver. If you push it, you're gonna blow it. And the problem is there's no clip light on this amp. So when you're setting the gains, you have no idea what to set it for. And that's why this happens. So yeah, 75 watts, it could be double that, but then it would be taxing the car's power supply, which is, I think, is just a compromise. 50 hertz spectrum, I did measure 50 hertz because it's a monoblock. We do have THD plus noise 0.075. Again, it's quite good. We have a second harmonic lower, almost minus 80, and third harmonic here, 62. So it is respectable. Yes, we do have all of this because, again, it's Class AB, it's underbiased. It does have quite a lot of these harmonics, which is expected, but THD-wise, the performance is respectable. Now, I did measure the efficiency of this amplifier, and it was 50%, as typical for Class AB. And now the most important thing is the frequency response. So I do have a few graphs. So the first one, the blue line, is the frequency response of this amplifier. This is 10 dB scale. So basically what's happening is that this amplifier is producing, if I'm going to just readjust it like this, we can say from 30 to 80. Everything else is going down and quite fast and quite a lot. We can see that it has kind of an almost infrasonic filter, because at 20 hertz, we are already down by 5 dB. So it is a very shallow slope. And at the higher frequencies as well, it drops off. You can see at 100 hertz, we already 3 dB down, and at 200 hertz, we are 10 dB down. Now, again, this driver is supposed to be used somewhere between 40 and maybe like 80. So it is kind of flat-ish in that region, but yeah, it's like this. This is the low-pass filter turned all the way up to 150 hertz. If you turn the low-pass filter down to 50, the lowest, it doesn't really do much. It looks like it just reduces the level, because that low pass, it affects literally everything, and 50 hertz is here. So that's why it looks like it removes the level. If this would be totally flat down to 10 or whatever, then we would see that this goes down and this goes flat, but basically it affects everything. So in reality, the low pass filter, it's very shallow, and it doesn't change the slope at all, almost. If I'm gonna bring the response a little bit up and align this range, you can see how the low-pass filter affects it. It just brings this down, but the linearity of the frequency response, it's kind of the same. And then the last thing, I tried a boost on the bass boost, plus 12 dB, and it basically does a bump at about 35 hertz, which is quite a huge bump, and at a very lower frequency. I was imagining that it's gonna be somewhere like 60, 70 hertz, but it's very, very low. So if you want that extra low end, you can boost it, but then the amplifier itself is gonna tap out very, very quick. So now, having in mind that the frequency response is centered about 40 to 70 hertz and everything is falling down, let's have a look at the RTA. So firstly, I measured it in the footwell as intended to be for a front subwoofer. Now, this is the same file that I used to measure all the other ones. So this is, for example, the Alpine shallow mount, the RS 10-inch driver, and I did say that it is a bit peaky compared to all the others. However, this ATOTO is even more peaky, and it plays a little bit higher. It does peak at about 75 hertz. If we're comparing this to, for example, stereo integrity, it's kind of almost the same. It's just the stereo integrity plays lower. I just need to realign this, something like that, so you can see this all traces like this, and the stereo integrity plays lower than this ATOTO. But in general, this performance is good for a front subwoofer. If you remember, this was my target for a front subwoofer. So if I would apply a low pass filter in the DSP, a little bit of EQ, even without EQ, probably it would need only a low pass filter, and it would match my target, my required target for the front subwoofer, almost ideally, which is amazing. If you remember, this was Alpine, kind of matches almost like this. The Dayton was matching even better, just needs a low pass as well. And the stereo integrity was like this, which is again, just needs some EQ. So yeah, as a front subwoofer, especially if you want to cross it a little bit higher, you wouldn't lose that much energy here and it would work perfect. One thing that I want to point out is this. This is a peak in the frequency response at 356 Hertz. If you remember, from here, we did have a blip in the impedance, and this is the cone breakup of the metal cone. We do have a very similar thing with the Dayton driver. So this is Dayton RTA, and this is near field. However, the Dayton one, I think it's a bit higher somewhere here, and I measured only up to 1K. But Dayton has it as well, massive, massive one. And this one has much lower in the frequency. So this is audible, and it doesn't sound nice at all. You can hear it even from the back, from the boot, and from the front as well. It's like extra energy in the mid-range. So this would need another low pass from a DSP just to cut it down, or cut it down with one EQ band, maybe like minus 15 dB. Just chop it off. But this needs taming and needs tuning out, because with this one, it doesn't sound good at all. Now, let's very quickly have a look at the distortion from the front subwoofer so that we can compare it with other drivers. Below, I want to say 55 Hertz or so, it's very good and it's manageable, 0.26%, very low and very nice. However, below 50 Hertz, the distortion rises all the way up to 6 to 7%, but this is at 35 Hertz. So this driver would need an infrasonic filter as well, maybe at like 35 Hertz, so that it would remove all the energy, like here, it will remove all of this bottom end, and at the same time, it would remove this distortion as well. Now, 5% at 40, 30 Hertz is not going to be audible, but if you push it, it will go up to 10, 20, and it will be audible. And this driver, it does kind of bottom out quite fast. So again, you need to manage your expectations and be realistic about the output. This is not a subwoofer designed to play down to 30 Hertz. You will need to put infrasonic on it, and then like from 40 and up, it would play very nice. Now for comparison, we can add stereo integrity. As I mentioned, for stereo integrity, the distortion rises as well because of the flat cone. Both of these drivers have a very, very flat cone. However, above like 50, it's kind of almost the same. So the Alpine distortion, I'm going to remove this, is much lower in the lower frequencies, and the Dayton is kind of there as well. So from this, you can see that the Alpine has much more distortion at higher frequencies compared to this ATOTO. This ATOTO is much cleaner above like 90 Hertz in the upper frequencies compared to a driver costing like 4 times as much and without an amplifier. Even the Dayton one, my beloved Dayton, yeah, ATOTO has lower distortion than the Dayton at higher frequencies, but much more distortion at the lower frequencies. Now, if we have a look at the impulse response, we do have Alpine. It has a little bit longer impulse compared to ATOTO. ATOTO has a shorter one. The Dayton has a much nicer impulse compared to this ATOTO, and stereo integrity has a very similar but a bit longer, because again, stereo integrity has a bigger cone and it is heavier, and this ATOTO has a much smaller cone. So again, not bad at all. And finally, let's have a look very quickly how this driver behaves in different locations. This is in the footwell. Under the seat is under the passenger seat. This is measured at the same level on the signal generator. So putting the driver under the seat makes it much more quieter. The frequency response doesn't change almost at all. However, you are losing almost 15 dB So putting a driver in the footwell, you have that loading from the footwell, the corner loading that adds, you can see 15 dB of output. Because under the seat, obviously the seat is going to absorb most of the sound and it's not coming out anywhere. But in the footwell, it goes directly to you. So footwell is a very good location, but the frequency response is the same. Under the driver's seat, we have a slightly different response. So under the driver's seat, it does play a little bit higher, but again, very, very similarly. In all the responses, we do have peak. That, as I mentioned, doesn't sound nice. So if we have a look at these two, this is under the seat. If you would install two of these drivers under the seat, you would have them peaking at about like 80 hertz. Now, you wouldn't be able to cross these under seats into like a 3 or 3.5 inch mid-range, because those mid-ranges will play maybe down to 200 acoustically, so there will be a gap unless you're gonna cut like 10 dB here and then make it a little bit flatter, but then you're losing already limited range. However, I'm thinking now that if you put an external amplifier on it, because this one has this frequency response, where at 2 hertz is already down by more than 10 dB. So if we would have a flat frequency response of the amplifier, we would gain at 200 hertz here, we would gain 10 dB. So the response would be here. And then potentially you could cross it into like a 3.5 or 4-inch driver. So I might try this active subwoofer on a different amplifier, just bypass the built-in one and see what happens. And lastly, let's have a look in the boot. This is the frequency response from the boot, from the corner of my boot where I always keep my subwoofers. And yeah, it does peak at 80 and it doesn't really play low. You can see the response just falling and falling and falling. You do have a little bit of boost from the cabin gain, but it doesn't do anything, and above 120, just as the cabin, it just falls off. I did measure a slightly different levels as well, so just for you to show the distortion from the boot, this is the red one at what, 75 dB level. We do have distortion 5% at 50 hertz. This is as well for some reason, and at 100 hertz is like 0.1, very clean. But at lower frequencies, yes, it has a lot of distortion, because the further it is from you, you are gaining a little bit of that bottom end due to the cabin gain, but you need to push this driver really hard. So if you push it harder, the distortion rises. Even harder, the distortion rises up to 10%. And this level is what? It doesn't even reach 90 dB from the boot, just because you need to push that driver really, really hard. In the intended range, like here between 70 and 150, you can see it's 1%. So it is kind of okay. But yeah, this is not a subwoofer designed to play very, very low frequencies. When you put it much closer, not in the boot, but much closer, and especially in the footwell, when you have that extra boost, then it doesn't have to work that hard. And this region where it's designed to be playing, centered at about 50 hertz, is kind of its sweet spot. So yeah, again, this is not a subwoofer for low frequencies. This is more of a mid-bass driver to replace rattling doors, or in my case, have it as a front subwoofer. So in summary, is this something that is worth your money and your attention? Now, this is going to be divided like into two things. If you expect this thing or similar product to this to perform as your main subwoofer, you will be disappointed, and I would not recommend using that. If you're smart about it, if you know the limitations of this thing and you have very reasonable expectations, this is going to perform as intended, obviously if it fits your install. Now for me, I will be installing this as my main front subwoofer. You will benefit massively if you're going to run it active through a DSP. This is exactly what I'm going to do, and in the future I'm going to make a video how to install it, how I tune it, and how I incorporate everything into the whole system as a front subwoofer. Now if we're talking about the price, £200, it might be too much for somebody, because probably you can find better value shallow mount subwoofer online, but is it going to perform the same? I don't know. Probably it's going to be very similar, but again, in my opinion, you're paying more for the customer service than the actual product. So if anything goes wrong, you know that you can get a refund, replacement, and your problems are going to be fixed and sorted. Now, while I was doing all this testing, especially when you saw what the built-in amplifier does, I'm thinking that this would really benefit from running this driver on a separate amplifier and a DSP. Now, if you want to see this in the future, pop a comment under the video. I might figure out how to run just a single wire outside of this enclosure into the amplifier, and we're gonna bypass the built-in amplifier because it's underperforming, it's not flat, it's not linear. Distortion is kind of fine for the intended purpose, but I think we could get much better results by amplifying this thing totally separate. So again, thank you very much, ATOTO. I always wanted to check out one of these shallow mount underseat subwoofers, woofers, mid-bass drivers, and now I have the chance. Now I know what it's capable of, and when somebody is gonna ask me for recommendations, I will know what to say, and hopefully you will as well. So thank you very much for watching, guys, and I will see you in the next one.